Hey guys, my name is Trevor Sullivan and welcome back to my video channel. Thank you so much for joining me on another topic where we're going to continue learning about LXD on Linux so that you can learn how to virtualize your own systems and containers as well. Now, one of the other topics that I wanted to cover in my LXD series is how to use a different storage driver, which is pretty common on Linux. It's known as LVM, which is short for Logical Volume Manager. And essentially what LVM is it's a way to organize your disks on your bare metal system so that you can expand and kind of cut up or carve up your storage over time in a way that works for your particular data structures. So what we're going to be doing is talking about how to actually set up LVM on a LXD virtual machine and kind of how it works, because it has some unique ways that it works. And I really like to use LVM just because it gives you that additional flexibility so that you don't necessarily have to make all of your partitioning decisions all the way up front. It gives you a lot of flexibility to add storage down the road, change the size of your different file systems, and also be able to reduce the size if you need to for some reason. So LXD has a built-in support for the LVM storage driver, and what we can do is create a storage pool on LXD in order to use a logical volume, or what's known as a volume group in LVM terminology, in order to store additional data volumes for your virtual machine infrastructure that you're creating on your LXD host. To give you kind of a quick visualization of what this looks like, we've got our LXD host right up here, and we have its root file system. So this would typically be /dev/SDA. Let's say maybe that's just a 10 gig root volume. But then if we want to attach additional data disks, maybe we don't have enough storage on this root disk here in order to store additional virtual machines, right? So what we do is we add additional physical disks. Maybe we plug in SATA-based solid-state storage. Maybe we add NVMe-based solid-state storage, or maybe even for whatever reason you choose to use traditional SATA-based hard drives as well. But what we can do is physically plug in additional disks into our LXD host. So maybe we mount it at /dev/SDB, and maybe a third disk called /dev/SDC. And for the sake of example, we're just going to say that each of these is 10 gigabytes as well. Now with LVM, what we need to do is basically register these disks, dev/SDB and dev/SDC, with LVM. So you have to make sure that you have LVM installed. First of all, you can do that with the apt package manager very easily. And then we also need to register these disks with LVM so that LVM is aware that those disks exist on the system and can be used to create an LVM volume group. So once we have these disks registered in, there's a command called pvcreate that we can use to register a physical disk with LVM. Then we can create what's known as a volume group by using the vgcreate command, and that'll allow us to basically pool multiple physical disks on the host together so that we can then provision logical volumes on top of that volume group. So then on our LXD host here, let's say that we wanted to provision a Linux virtual machine running something like Ubuntu Linux server. Well, what we can do is actually configure a storage pool on LXD to use this LVM volume group as a storage pool. And then when we deploy this virtual machine up here, we can configure the root file system for that virtual machine to actually have its volume stored on our LVM storage pool instead of the default ZFS storage pool, which typically resides on your root file system disk. Now, once we've stored our root file system for our virtual machines on top of our LXD host into our LVM volume group, that gives us some additional capabilities, because this volume right here isn't actually restricted to just the size of one of these disks here. Because we actually have two 10 gigabyte disks combined together, we can technically have a 12 gigabyte volume, and that volume on LVM will actually span both of these physical disks in the system. So this is really nice because not only do we have these physical disks attached to the system, but we can pool their capabilities, pool their storage together so that we can actually create larger volumes than just one of the physical disks by themselves. So I really love LVM because it gives you this flexibility. And also, once you've created an LVM volume group, you can actually add additional disks to it as well. So if we came in and had maybe another 100 gigabyte SSD, we could just register that with LVM, add it to our existing volume group down here. And just like that, we've expanded the size of our volume group so that we can add more and more virtual machines, but without any additional management overhead of having to manage a totally separate disk on the system, because we're just bringing it under the management of the LVM volume group. So we're going to take a look at how this works in practice. We're going to go ahead and launch a LXD host. We'll attach a couple of additional data disks to that system in addition to its root file system over here. And then we'll take a look at how to actually create the volume group and then register the volume group as a storage pool with LXD itself. And then we'll see how we can create a virtual machine that uses that volume group for the VM's root file system. All right, so what I'm going to do is go ahead and jump over into my shell here, and I'm going to pull up one of my bare metal hosts that I have running the LXD service here. And I'm going to go ahead and actually launch a new virtual machine under this bare metal system. And that's going to serve as our demonstration environment, because I can use my bare metal host to create logical volumes and then simply attach them as data disks to my virtual machine. And then we'll be able to create a kind of second tier nested virtual machine on top of that virtualized LXD host. So for starters here, we're just going to go ahead and launch a LXD host. We'll say LXC launch. I'll do --config limits.cpu equals 3, just to give it a little extra CPU processing to delegate to its virtual machines. Then I'll do config limits memory, and we'll just give it about 8 gigabytes of memory. And then we'll use the Ubuntu lunar image right here. And we're also going to just give it a name like LXD01. Now, the default root file system is going to be 10 gigabytes, and that should be perfectly fine. You can make that bigger or smaller if you want to by tacking on a device override as well, but this should be fine for now. Also, I need to make sure I do --VM here. Otherwise, it's going to try to launch a container instead of a virtual machine. So make sure it says --VM. So now what we're going to do is just look at that virtual machine, make sure that it comes up and running, and then we are going to make sure that LVM is installed on that system, and we will go ahead and create our LVM volume group. So now that the VM is up and running, which I can see by looking at its IPv4 address that it gets from the bridge network, we'll go ahead and exec into that VM. So we'll run bash on there. And if you run just something like vg create here, and if that command works and you see that it just prints out the help here, that means that LVM is already pre-installed on your system. Also, if we run LXC version here, I just want to make sure that LXD is pre-installed. So we'll do LXC version and make sure that it prints back the latest version here of LXD. So we've got LVM and LXD installed. So now what we can do is to actually use LVM to create one of these volume groups. But first I have to attach a couple of additional data disks to this virtual machine. So I'm going to go ahead and fire up another session here on my bare metal host, and we're going to go ahead and create a couple of custom storage volumes, and then we're going to attach those to the LXD01 virtual machine. So let's do an LXC storage volume create, and I'm going to create it on my default storage pool, and we can just give the volumes a custom name, and we can also set the size of each of those volumes. We also need to make sure that we specify the type of block, because the default type is going to be a file system that can be shared amongst multiple virtual machines. So we want to make sure that we are provisioning a block storage device. So let's do storage volume create, type equals block. We'll put it onto the default storage pool, and I'll call this data01, and we'll set the size property here to, how about 10 gigabytes. All right, so now that we've created one, we'll create a second one as well, and then we need to make sure that we attach these to the LXD01 virtual machine. So let's list those volumes. do LXD storage volume list on the default storage pool. And now you can see right here in the table, we have custom data 01 and custom data 02. So we can attach both of these volumes as additional data disks to the LXD01 virtual machine. To do that, we say LXC storage volume, and then we'll plug in the attach command right here to attach a volume to a virtual machine instance. So let's do attach -- help. And then we can specify the storage pool where the volume belongs. Of course, that's our default storage pool. The name of the volume, data 01 and data 02, and then the name of the virtual machine that we want to attach it to. So let's run attach, specify the default storage pool, data 01, and we'll attach it to the virtual machine called LXD01. All right, that seems to have worked just fine. So then we'll attach the data 02 disk to LXD01 as well. And so now we've got both of these disks accessible to our virtual machine. So let's switch back over to our virtual machine's shell right here and use the LVM tools to make sure that we create or register the physical disks for starters with LVM, and then we'll create the volume group. So if I run lsblk, this is just a standard Unix command that allows us to see the block storage devices on our local system. So SDA right here is the root block device for the actual operating system disk of the virtual machine. But then SDB and SDC, you can see those are both 10 gigabyte disks that we just attached to this system, right? So SDB and SDC are the two disks that we're going to register as a volume group with LVM. So the first thing we need to do is run the pvcreate command, and this is going to allow us to specify the path to a physical volume. Technically, these are virtual disks because this is a virtual machine, but from LVM's perspective, it's a block device that's attached to the system, and this will register the physical disk with the LVM service, and then we can go ahead and create the volume group with those physical disks that have been registered. So if we do pvcreate/dev/sdb, that will register. It's kind of deceiving terminology here because it says it created a physical disk, but really what happened is the disk that's attached to the system is registered with the LVM service. And then we can also do pvcreate dev SDC as well, and that'll make sure that both disks are attached to LVM specifically. So now there's another command called pvdisplay that we can use to show and just verify that the disks actually are present in LVM. So you can see dev SDC, exactly 10 gigs, and dev SDB, exactly 10 gigs. LVM is aware of both of those disks by way of running this pvdisplay command. Now, once the LVM service is aware of both of these disks, we can create a volume group that encapsulates both of those disks. Or we could just start with one disk, and then later on, we could add a second disk. So to do that, we say vg-create, then we specify a name for the new volume group that we're creating, and we can specify one or more physical volumes that we want to include in the volume group. So we'll do a vg-create. I'll just call it Trevor LXD, and we'll specify /dev/sdb for now. And I'm going to leave the other /dev/sdc disk free so that we can do additional things with it later on. All right, so what we're going to do now is just run vg-display, and this is going to show that we have a volume group with the name Trevor LXD, and it has a total size of 10 gigabytes. And these are the physical extents, or basically the blocks of storage. Each physical extent is 4 megabytes in size, 4096 kilobytes essentially. And so now we have one disk that's been registered with this volume group, and we can now register this volume group with the LXD service so that we can use it as a storage pool. So to do that, what we're going to do is just register this here. There are some configuration options that you can set at registration time. So for example, we could disable the use of thin pool, which actually allows us to over-provision storage on the volume group. I'm going to go ahead and disable that. We can also specify things like what the source volume group is, because we have an existing volume group. And we could also specify things like size here. So what's the size of our storage pool? And there's a bunch of other options in here as well. So what we're going to do, I think, is probably use force reuse here because we are using an existing volume group as well. So we'll go ahead and use the LXC command here in order to create that pool. So to do that, we'll go into the storage context right here in LXC, and we're going to create a new storage pool. So we'll say LXC storage create. Then we specify a name for the new pool that we want to create. We specify the LVM driver, and then we can specify the options for the storage pool that we want to use during the creation time. So first it's going to be the pool. I'll just call it Trevor LXD. Then we're going to use the LVM driver. And then finally, we can specify some of these options right over here. So we're going to set LVM use thin pool equal to false. And then we're also going to set the source down here. We're going to set that to Trevor LXD because that's the name of my storage pool. And then I'm just going to set LVM volume group force reuse, set that to true because we have an existing volume group already. All right, so we've registered the storage pool. So LXD is now aware of our LVM volume group. And if we try to launch a virtual machine on that volume group, it should work perfectly fine. So let's do an LXC launch --VM, and then we'll specify --storage equals Trevor LXD. That's the name of our storage pool that we just created. And then we'll specify an image like Ubuntu Linux, and then I'll just call the virtual machine U01. And we could also do a override on the device size. So I'll set the device root size equal to, how about 4 gigabytes instead of the typical default, which is 10 gigabytes. So out of our 10 gigabyte volume, we're only going to chew up about 4 gigabytes for this one particular virtual machine. And then we'll create some additional virtual machines to see how we can fill up the storage on the one disk, but then we can go back into the volume group, add the second disk, and expand our storage dynamically. So as soon as this image downloads, we'll come right back and finish the rest of the video. Now, I just realized that I totally forgot to run through the LXD init wizard, so we don't have a bridge network to associate with our virtual machines. So it's complaining that we don't have any network interfaces attached to our VMs, but that's totally fine because we don't really need to do anything with the virtual machine. We just need to provision it and see how much storage it takes up. So now that we've launched this virtual machine, how do we actually see the storage that it's using? Well, we could use lsblk right here, and we can see that under /dev/sdb, we have a block device here that is 4 gigabytes in size. So this block device right here is actually the device that's been attached to our virtual machine for storage. And you can see that our actual disk size is 10 gigabytes. So out of that 10 gigabyte disk, we've only provisioned about 4 gigabytes plus 100 megabytes here. That's probably for the EFI system partition that's used to actually boot the system. Now, another thing that we could do is run VG display right here, and this is going to show us that the allocated portion of our physical extents on that virtual disk are 1049 times 4 megabytes, which gives us about 4.1 gigabytes right here. And we still have 5.9 gigabytes free on this particular volume group, right? And the volume group only currently contains one of our 2 data disks that are attached to the system. So if we try to launch additional virtual machines, we should be able to create a second one with a size of 4 gigabytes because the first one of 4, the second one of 4 totals up to about 8 or 8.2 gigabytes. And so we should be able to easily fit that into our 10 gigabyte volume group, right? So now our allocated portion is 8.2 gigs and we have 1.8 left. So since we only have 1.8 left, what's going to happen when we try to launch a third virtual machine? Well, LXD is going to try to create another root file system for this new virtual machine with a size of 4 gigabytes, but because we only have 1.8 gigabytes left, we simply don't have enough space on the disk. And as you can see, it says 1024 physical extents are required, but we only have 461 physical extents or blocks remaining on that storage device. So what we can do at this point is, thanks to LVM's flexibility, is just go in and add another disk into the volume group, and that will expand the total available storage for the volume group to a larger size so that LXD can make use of it. So if we run VG display again here, just take a look at the total storage here, it's 10 gigs. And so now what we're going to do is say VG, and we're going to run VG and then extend right here. And the VG extend command allows us to add additional disks to the volume group. So we'll say VG extend, and then we just specify the name of the existing volume group, which is just Trevor LXD. And then we specify the physical disk or physical volume that we want to add to the volume group. So we'll plug in Trevor LXD and then /dev/SDC. That's the disk that we want to use to extend our volume group. And now if we come back and run VG display, you can see that we've expanded our 10 gig volume group all the way up to just shy of 20 gigabytes. So now we have 3,020 free blocks of 4 megabytes each, and that gives us about 11.8 gigabytes of available storage. So if we try to launch another virtual machine on our host right here, let's go ahead and rerun this command here to create virtual machine U03. We should have enough free storage to create that virtual machine, as well as even a fourth virtual machine if we wanted to. This is just unpacking, and as you can see, we were successfully able to create this virtual machine. And so now our storage is exceeding 10 gigabytes of allocated space. Now we're up to about 12.3 gigabytes of used space, thanks to our ability to, again, pool those LVM disks together. So again, LVM is really powerful. It's really flexible. It allows you to slice and dice your storage in a very flexible fashion. It allows you to make decisions after the fact that you may not necessarily have answers to all the way up front when you're provisioning your storage. So I would strongly encourage you to use LVM with LXD to manage your physical storage. I hope you guys enjoyed this video. If you did, please leave a like on this video. Also, subscribe to the channel. Check out the other videos in the LXD playlist and the other playlists that are on my channel, and we'll see you in the next video. Take care.